Good morning, ma'am. This is Namrata, holding pin number 15 from CSEH. Today, I am going to explain the topic about memory connection to CPU. In this topic, memory connection to CPU, RAM and ROM chips are connected to the CPU. First of all, we'll discuss about the RAM chip. RAM chip is used to communicate with the CPU, and RAM chip is used for read and write operations. Now, the block diagram of the RAM chip. The capacity of the memory is 128 words of 8 bits per word. This requires a 7-bit address and an 8-bit bidirectional data bus. Now we are looking the block diagram of RAM chip. It is of 128 into 8 RAM. It consisting of two selection lines, that is CS1 and CS2 bar, and it also consisting of RD, read pin, and WR, which is the write pin, and it consisting of the address line 7-bit address lines AD0 to AD7. Considering 128 into 8 RAM, the 128 which is represented as 2 power 7, so it takes 0 to 7. That means the 0 to 7 are used for the address lines of the 7-bit of the RAM chip 7-bit address AD0 to AD7. Now it also consisting of 8-bit bidirectional data bus. Second, we'll discuss about the ROM chip. ROM chip is used for only read purpose, and the block diagram of the ROM chip. The capacity of the ROM is 512 byte, and the 9 address lines in the ROM chip specifies any one of the 512 bytes stored in it, and it also consisting of 8-bit data bus. The block diagram of the ROM chip, which is 512 into 8 ROM, it consisting of two selection lines, CS1 and CS2 bar, and it also consists of 9-bit address lines AD0 to AD9. The 512 of ROM chip is represented as 2 power 9. That means 0 to 9 are considered as the address lines AD0 to AD9. And it also consisting of a 8-bit data bus. This is about the ROM and RAM chips. Now coming to the memory connection to the CPU, the overall 1024 address is divided into half, that is 512 for ROM and 512 for RAM and ROM. And the 512 RAM, that is the RAM size is 128, and here the 4 RAMs are required to make the RAM size to 512, and the ROM size is 512, so 1 ROM is required for the construction. Now the address lines of the RAM, which is 128, is the size of the RAM, so 2 power 7. That means 0 to 7 address lines are required, and the address lines of the ROM, which is 512, 2 power 9, 0 to 9 lines are required. The decoder which we are using is 2 into 4 decoder. That means the 128 into 4, which makes the overall size of RAM is 512. So to operate with the with the specific RAM, the 2 into 4 decoder is used for 4 RAMs. This is the memory division and the size division of the 1024 of memory connection with the RAM chips and ROM chips to the CPU. Now coming to the construction, it consisting of CPU, and it consisting of 4 RAM chips 128 into 8 and 1 ROM chip which is 512 into 8 are used. RAM and ROM chips are connected to the CPU through the data and address bus. Here we are using the address bus. Address lines for this is from it takes from 1 to 16 address lines, and the lower order line 1 to 7 in the address bus. Select the byte within the chips. Each RAM receives the 7 lower order bits of the address bus to select one of the 128 possible bytes, and the particular RAM chip is selected is determined from the lines 8 and 9 in the address bus. This is done through the 2 into 4 decoder, whose output goes to CS1 input in each of the RAM chip. Thus, when the address lines of 8 and 9 are equal to 0, 0, then the first RAM is selected for the operation, and if it is 0, 1, then the second RAM is selected. When it is 1 0, the third RAM is selected, and when it is 1 1, the fourth RAM is selected. Now coming to the address line, which is 10, the selection between the ROM and RAM is achieved through the bus line 10. The RAM are selected when the bit is 0 and is connected to the CS2 input of each RAM chip, and the inverter is connected to the CS2 input of the ROM chip. That is, when the bit is 1, then the ROM chip is selected for the operation. Now coming to the read and write pins, the read output from the microprocessor are applied to the output are applied to the input of each RAM chip for the read operation, and the CS1 of the ROM chip is connected to the RD control line from the ROM chip to enable during the read operation. Only during the read operation, the RD bar is connected to the ROM chip of the CS1 line. Now coming to the WR bar, the WR line, that is right line is the output from the microprocessor are applied to the inputs of the each RAM chip for the write operation. Only for the write operation, the WR pin is connected to the every RAM chip, and the WR is connected to only the RAM chips but not the ROM chip, because the ROM chip is used only for the read operation and the RAM chips are used for read as well as the write operation. And at last, the address lines. The address lines 1 to 7 are connected to the ROM, but the ROM takes the address lines from 0 to 9. So the two address lines should be connected to the ROM. So the two address lines are taken from the address bus 8 and 9 are applied to the input address of the ROM without going through the decoder. These two lines are connected to the ROM chip address lines. Now the overall address lines of the ROM chip becomes AD0 to AD9. That means 1 to 7 are separate and 8 and 9 are connected separately. This is the complete explanation about the memory connection to the CPU of when the size is given of 1024, and if the size is given more, then the selection of RAM chips and ROM chips will be increasing. Example, if it is 2048, then 1024 for RAMs and 1024 for ROMs is divided, and when it is 2048, will be taking 8 RAMs instead of 4 RAMs. So this is the different RAMs or memory selections for different sizes, and this is only the example of 1024 memory connection, 1024 size of memory connection to the CPU. And next, this is the complete explanation about the memory connection to the CPU, which I have explained in the diagram in the animated way. And this is the explanation. This is also the explanation. And thank you for watching.